We already did this problem in the previous video using critical values, the classical approach. In this video, we are going to do the same problem, but using p-value approach. This study is about obese people on a low-fat diet and regular diet. We want to compare the weight losses for the two different diets. We want to test the hypothesis that the low-fat diet is more effective than the regular diet. The significant level in this test is 5%. Alpha is equal 0.05. This researcher is willing to make a mistake only in 5% of the cases when he selects the samples. The first three steps, step 1, 2, and 3, are the same for both methods, critical value and p-value. In this video, I am going to explain only the step number 4 in the p-value procedure. Our claim is that the low-fat diet is more effective than the regular diet. That implies that the mean weight losses of the low-fat diet is bigger. People lost more weight on this diet than in this other diet. This is our data. This is our evidence. Let's do this problem using technology StatCrunch in seconds. Let's send this data to StatCrunch. We have to organize our data in two columns because we have two populations. In this column, we have the weight losses for the low-fat diet, and in this other column, the weight losses for a regular diet. For each diet, we have 100 of these people. That is the result, 100. To obtain the answer in StatCrunch, go to Stat, go to ZStat, because my samples are big. If my sample were small, we have to use Tstat. Remember that. Because we are dealing with two populations, we select two samples. And we have the raw data, not the summary. Let's select with data. Then our first sample is located in this column, low-fat diet. And our second sample is located in the second column, regular diet. We can do hypothesis test or confidence interval. We can obtain from those data confidence interval also when you click here. But this time we are going to do hypothesis tests. The null hypothesis states that there is no difference between these two diets, and the alternative hypothesis is our suspicion, which states that this mean weight losses is bigger than this. If mu1 minus mu2 is positive, that indicates that mu1 is bigger than mu2. Then let's click compute and we obtain all answers. We have 100 observations for each sample. That is the difference of the two samples mean. That is the standard deviation of all difference. When we take two samples, the difference of all two possible samples selected from both diets. And this is the C-score of this value. And this one is the p-value. My assumption states that the difference is 0, but we got a difference of 1.91, and this is located 3 standard deviation to the right. Then the p-value is 0.01. Then this value is too small. If the p-value is smaller than alpha, alpha remember is 5%, 0.05, we can conclude that my evidence falls far away from the center. The center is 0. The expectation is 0. The assumption is 0. The difference is 0. Because my p-value is smaller than alpha, we reject the null and we support the alternative. Then we support that the low-fat diet is more effective than the regular diet. It is very easy to solve this problem using a StatCrunch. For that reason, I will request in the proctor test that you show your work. You must show your work on a piece of paper. You need to write down in this piece of paper all steps, all instructions that a person that doesn't use technology must follow to obtain these answers. You must use only formulas and tables, pretending that you don't use technology. Let's test the hypothesis that the low-fat diet, the average of weight losses is bigger than a regular diet. Let's test this hypothesis using the p-value approach, not the classical approach using critical value. To do the critical value approach, we need 3 information in the same way that we need 3 information to find the critical value or reference point. These 3 information that we need are the distribution, the kind of test, and the evidence. The most important of them, obviously, is the evidence. The evidence must be condensed in one score in the C z-score. The z-score was 3.0 something. The kind of test in this case is a right-tail test. It means that my p-value is probability to the right, because p-value is the probability to get one value equal to my evidence or more string in the direction of the alternative. If the alternative is right, the right direction. If the alternative is to the left, in the left direction. If my alternative is two-tail test, we need to multiply the extreme area by 2. Then in this case, it's a right-tail test. Then we need to find my evidence. My evidence was the z-score, how far away fall my difference from my assumption. The difference was 0 in my assumption. Then the difference we obtained was 3.09. The p-value should be the probability to get this evidence 3.09 or one evidence more extreme in the direction of my alternative to the right. We can do this using technology very easy in seconds. But if you want to find only the p-value using technology, you can go to Stat, Calculator, and Normal Distribution. In the Normal Distribution, you select Normal Distribution, and after that, you need to input the z-score. The p-value is the area to the right. The z-score is 3.01. Then the p-value is this area to the right, because my alternative was to the right. Then I want to find this area. I need to select this symbol, which is greater than, and input in the next box my test statistic, my evidence. Then my evidence was located 3 standard deviation to the right. What is the probability to get one evidence like this or more extreme? This probability is 0.001. It's less than 1% of the cases. Then for that reason, we have enough evidence to reject that these mean are equal. Then how can we do this using table? Because my evidence is positive z-score, we need to use the positive z-score table. In the positive z-score table, we need to find 3.0 in this column, and the second decimal 9 must be found in this row. In this intersection between this row and this column, we have this number, and remember, this number represents probability to the left. Probability to the left of this point is this probability, but the p-value is the complement of this. Then the p-value must be calculated in this way using table. P-value is equal probability that the z-score is greater than 3.09. That is the definition of p-value. And how can we obtain this value using table? Is 1 minus the value that is given in the table, that is probability to the left. Then this value is the same value that we obtain using technology. It's the same value that we obtain using technology. That is your work. This explanation, this table, and this graph is your work. You need to do all of this to show your work. And because my p-value is smaller than alpha, remember alpha is 0.05, then which value is greater? Obvious, this value is greater. If the p-value is smaller than alpha, then I reject the null. When I got a p-value small like this, it's because my evidence fall far away from the center. But if I get a p-value bigger than this, is because my evidence fall close to the center. Then in this case, because my p-value is smaller than alpha, I'll reject the null. That is the conclusion. Reject the null hypothesis and support my suspicion that the mean for all of these people that are on their low-fat diet, the mean weight losses is bigger than a regular diet.